Welcome children. Today is worksheet number 67, Work and Energy. In this worksheet, we will learn about kinetic energy. What is kinetic energy? There are different forms of energy in nature. You know, there are different forms of energy present in nature. An object possesses kinetic energy while it moves. It means a moving object can do work. An object moving faster can do more work than an identical object moving relatively slow. So, an object at rest does not possess kinetic energy. If an object at rest, it does not possess any kinetic energy. Examples of objects having kinetic energy: running water, moving car, rolling stone, or moving bullet, or blowing air, or blowing rotating wheel, or blowing wind, or you can say moving bullet. All these are examples of objects having kinetic energy. So how will you define the kinetic energy? Kinetic energy of an object is defined as the energy possessed by an object by virtue of its motion. Means energy due to the motion is called kinetic energy. The kinetic energy of an object depends upon, first one is mass. It depends upon mass of the object. If the object has more mass, its kinetic energy will also be more. And also velocity. Kinetic energy depends upon velocity of the object. If the velocity of the object is more, then it will have more kinetic energy. Now we will discuss mathematical expression for kinetic energy. So let us consider an object of mass m moving with a velocity u displaced to a displacement s. Means s represent displacement, u is initial velocity, and mass of the object is m. Let us force F be acting on it and product an acceleration a. Acceleration is a to increase the velocity v. Therefore, work done is equal to, work done is equal to W equal to F into S. This is your first equation. From second law of motion, F equal to ma. This is your second equation. If we place the value of F in the equation 1, we will get W equal to ma into S. Now, from third equation of motion, V square minus u square equal to 2as. If we find out the value of s, it will be equal to v square minus u square upon 2as. Now we place the value of s in the equation 3. If we place the value of s, v square minus u square upon 2a in the equation 3, we will get W is equal to ma into v square minus u square upon 2a. So W will equal to half m within bracket v square minus u square. If the object is at rest initially, then value of O will be 0. So W will equal to half mv square. This is the formula for calculating the kinetic energy. Kinetic energy denoted by EK. E means energy and K means kinetic. So EK will be equal to half mv square. For an object at rest, U is equal to 0. Therefore, kinetic energy of an object at rest is 0. Now some numericals are given to you. First one is an object of mass 10 kg is moving with a velocity of 4 meter per second. Find out the kinetic energy it possesses while it moves. So you have to find out or calculate the kinetic energy. You know the formula of kinetic energy. Half kinetic energy is equal to half mv square. So we put the values of m and v in the equation or in the formula. We will get half 10 multiplied by 4 square, because the velocity of the object is 4. So v square, 4 square, 2 1 are 2, 2 5 are 10, and this will be equal to 4 square of 4 is 16. So when we multiplied 16 multiplied 5, we will get 18 joule. Now second example. In second example, calculating the work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour is the mass of the car is 1500 kg. So mass is given to you and velocity, initial and final velocity given in kilometer per hour. First of all, you have to convert this kilometer per hour into meter per second. When we have to convert, by converting this, we will multiply the kilometer per hour by the 5 upon 18. So when we multiply 30 multiplied by 5 upon 80, we will get the value in meter per second. Now work done will be equal to change in kinetic energy, means final kinetic energy minus initial kinetic energy. So we have to find out kinetic energy final and initial, and in the last we will subtract this final kinetic energy minus initial kinetic energy, and we will get the work done, which is equal to change in kinetic energy or kinetic energy, value of kinetic energy. Now we will discuss question answer. Your first question is define kinetic energy, also write its formula. So formula of kinetic energy is this one. This is the formula of kinetic energy. Ek is equal to half mv square, and definition of kinetic energy given in the worksheet. You can write kinetic energy of an object, this one, is defined as the energy possessed by an object by the virtue of its motion. Question number 2. Question number 2 is, what would be kinetic energy of a car standing in a garage? If the car is standing, so object is at rest and u will be equal to 0. So kinetic energy of an object at rest is 0. So answer of question number 2, the kinetic energy of a car standing in a garage will be 0, because kinetic energy of an object at rest is 0. Question number 3, on what factors does the kinetic energy of an object depends? So there are two factors. What are they? These are mass as well as velocity. Kinetic energy of an object depends upon mass and velocity of the object. Mass of the object and velocity of the object. If the mass of the object of an object is more, then velocity or kinetic energy will also be more, and also if the velocity of the object will be more, its kinetic energy will also be more. Question number 4. In question number 4, you have to give in a numerical. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. What will be the kinetic energy when its velocity is double? If the velocity is double, what will be the kinetic energy? So you can find out in this way. You have to give in initial kinetic energy 25 joule, and you know the formula of kinetic energy. What is the formula of kinetic energy? Ek will be equal to half mv square. This quantity is constant. M is constant and 1 upon 2 is constant. So we will get Ek is directly proportional to V square. Kinetic energy V square के directly proportional होती है. When its velocity is double, its kinetic energy will be Ek is equal to 2 square into initial kinetic energy. So square of 2 will be 4 and multiplied by initial kinetic energy, that is 25. So its value will be 100 joule. It means kinetic energy will be increased 4 times. 25 is to 100. When the velocity is double, 25 1 ja 25, 25 4 ja 100. So when the velocity of an object is double, its kinetic energy increases 4 times. Question number 5. In question number 5 is also a numerical. Certain force acting on 20 kg mass changes its velocity from 5 meter per second to 2 meter per second. Calculate work done by the force. You have to calculate work done. So how will you calculate the work done? You have to give in mass 20 kg, velocity changes from 5 meter per second to 2 meter per second. It means value of u is 5 meter per second and value of v is 2 meter per second. You have to find the kinetic energy for both the cases. In first case, we will put the value of u 5 meter per second. So half multiplied by 20 multiplied by 5 का square of 5. So we will get 2 1 ja 2, 2 10 ja 20. So 10 multiplied by 20 square of 5 is 20, and kinetic energy, value of kinetic energy will be 250 joule. In second case, that is final velocity, we have to place in this equation. So 1 upon 2 multiplied by 20 multiplied by square of 2. So 2 1 ja 2, 2 10 ja 20. So we will get 10 multiplied by square of 2 is 4. 10 multiplied by 4, it means 40 joule. This is final kinetic energy. You know work done is equal to change in kinetic energy. Final kinetic energy minus initial kinetic energy. So we will minus final kinetic energy. Final kinetic energy is 40 and initial kinetic energy is 250. Now by the subtracting these, we will get minus 210 joule. It means minus sign express that speed of car or speed of vehicle is decreasing. Thanks for watching.